All the students, today we'll discuss the questions related to metallurgy, that is metals and non-metals, and those questions are based on to the IGS level. Here's question number 1 is, in which of the following pairs options are sylvine, saltpeter, second one is cassiterite, litharge, diorite, option D is cuprite, tin stone. Now, we'll focus onto the formulas, chemical formulas of all these ores or the minerals. Sylvine, it's a mineral of the potassium and the chloride. Saltpeter, again, saltpeter are of two types, chili saltpeter and then Indian saltpeter. Chili saltpeter is a nitrate of sodium and Indian saltpeter is a nitrate of potassium. If in exam they ask you what is saltpeter, we'll consider Indian saltpeter as saltpeter, that is KNO3. Now, cassiterite. Cassiterite is an oxide of tin, that is SnO2. Litharge, it's an oxide of lead, that is PbO. Option C, siderite. So here both the pairs are oxide, that means option B is correct. Now we'll check onto the further option whether they are right or wrong. Siderite is a carbonate of iron, that is FeCO3. Corundum. Corundum is an oxide of aluminium, Al2O3. Here one pair is correct but the another one is wrong. So this is not the right answer. Cuprite, which is an oxide of copper, that is Cu2O. And then tin stone, which is an oxide of tin, that is SnO2. Here both the pairs are correct, which are the oxides of minerals. So we'll check B and D, both are the correct options. Both the pairs are correct. Cassiterite, which is an oxide of tin, litharge, which is an oxide of lead, cuprite, which is an oxide of copper, and the tin stone, which is an oxide of tin. So in this case, both the minerals pairs are oxides. The next question, which of the following will be a correct statement? Which of the following, the given option is a correct statement? Option A, calamine is an ore of zinc. Option B, pyrolusite is an ore of magnesium. Cassiterite is an ore of tin. And D is calcite is ore of calcium. So let us check the formula of all these ores, whether they are correct or not. Calamine, it's given in a statement, it's an ore of zinc. The formula of calamine is ZnCO3. That means it is a correct option. Now we'll see pyrolusite is an ore of magnesium. Pyrolusite is MnO2. This is an ore of manganese and oxygen. So here metal present is manganese, not the magnesium. That means this is not a correct statement. Again, cassiterite is an ore of tin. The formula of cassiterite is SnO2. Sn is a symbol of tin, that is stannum. That means this is a correct statement. Then calcite is ore of calcium. Calcite is CaCO3. Yeah, it's a correct statement. It is a ore of calcium. It is a carbonate ore of calcium. That means option A, C and D are correct. Now let's switch on to the third question. In the extraction of aluminium metal, one of the process given below is summarized as follows. It is summarized. First one, the given reaction is Al2O3 thrice H2O, which is an impure ore of aluminium, that is bauxite. This on heating in a presence of hot concentrated A gives product B, which will be the aqueous solution, which when passed into the bubble gas, that is C, so as to change its pH, gives a pure alumina, that is Al2O3, pure bauxite, that is Al2O3 dot thrice H2O, which when mixed with D, it gets melt at 1000°C, and here further electrolysis takes place so as to give the aluminium at E. Now in the given reaction we have to identify what is A, B, C, D and E. Now we'll focus on to the reaction again. Al2O3, that is impure bauxite, when treated with a hot concentrated A. Here A is NaOH. Now NaOH, being an alkali, reacts with an oxide which is amphoteric in nature. If here NaOH is reacting as a base, then Al2O3 will react as an acid, because the nature of Al2O3 is both acidic as well as a base. So here Al2O3, it acts as an acid, and NaOH, which is acting as a base. When acid reacts with base, there will be the formation of salt plus water. Here salt is NaAlO2 plus H2O, which will be the aqueous solution of sodium aluminate. So the product B will be sodium aluminate and the product A will be the sodium hydroxide. So we have identified what is A and what is B. Now we'll see further reaction when a bubble gas C is passed onto the sodium meta-aluminate. It gets converted into pure alumina. That gas is carbon dioxide. When carbon dioxide is passed onto the aqueous solution of the sodium meta-aluminate, it forms pure alumina, that is Al2O3 plus, again there will be the formation of a salt, that is Na2CO3. Now when this Al2O3, here Al2O3, this will be the pure alumina. When this pure alumina is mixed with D, as the melting point of alumina is very high, so it will be mixed with the cryolite, that is Na3AlF6, so as to lower its temperature, and it melts at 1000°C. Na3Al, the use of Na3AlF6, that is cryolite, is to lower down its temperature. That means the temperature of alumina, and further the electrolysis of the aluminium oxide takes place. This aluminium oxide get reduced into aluminium plus oxygen, and thus this aluminium get deposited, metal get deposited at the cathode, because the reduction of the metal takes place, and here oxygen gets deposited at the anode, because here the oxidation of the non-metal takes place, whereas the reduction of the metal takes place, as we have to extract the aluminium from the impure aluminum. In this way we can easily extract the aluminium from the impure bauxite, that is Al2O3 dot thrice H2O. So in the above equation we'll wind up, what is A? A is NaOH. What is B? B is CO2. What will be what is B? B is NaAlO2. This will be C, and B will be NaAlO2. What will be D? D will be Na3Alf6, that is cryolite. And what will be the option B? Deposition at the cathode. Now we'll see the next question. It is a paragraph based question. The reaction, you should have to complete the reaction, that is FeCl2O4 parachromate when reacts with NaOH in a presence of air, it forms A plus Fe2O3. This A, when reacts with B, it forms Na2Cr2O7. This Na2Cr2O7, when reacts with X on heating, it forms Cr2O3. Now further, this Cr2O3, when reacts with Y on heating, it gets reduced into chromium. Now what we have to identify is, what are the compounds A and B, what is X and Y in the given reaction, and how will we separate Na2Cr4 and Fe2O3. Now we'll see the reaction. In the first reaction, FeCr2O4, when reacts with NaOH in a presence of air, it forms Na2Cr4 plus Fe2O3. Now, as this is a salt and this is an oxide, now we have to separate the Na2Cr4 from the Fe2O3 for the further reaction. Now how we will separate? We make the use of the concentrated H2SO4. When we dissolve the Na2Cr4, that is sodium chromate, in a concentrated H2SO4, it forms Na2Cr2O7. That means we can easily separate sodium chromate and Fe2O3 by dissolving the sodium chromate in the concentrated H2SO4. Now further, as we have seen, when we have reacted the sodium chromate with a concentrated H2SO4, it has formed sodium dichromate along with the H2S gas. This sodium dichromate, that is Na2Cr2O7, when it reacts further with carbon, here carbon acts as a reducing agent. So what will happen? Here the chromium gets reduced into Cr2O3, as here if we find out the oxidation state of chromium, now the oxidation state of sodium is 1, 2 atoms are given, so it will be 2 plus 2x, plus the oxidation state of oxygen is -2, here 7 atoms are given, so it will be -14, and we'll equate it with 0, so it will come out to be 2 plus 2x minus 14 equal to 0. So 2x equal to 12 and x will equal to 6, and here the oxidation state of chromium comes out to be 2x plus minus 6 equal to 0, 2x equal to 6 and x is equal to 3. As carbon acts as a reducing agent, it will get oxidized and Na2Cr2O7, here the chromium gets reduced. Here carbon acts as reducing agent. Now what we have to do, we have to extract the metal, that is chromium, from the chromium oxide. Again we will make the use of the another reducing agent, that is Cr2O3 when reacts with aluminium. As aluminium is present above chromium in the reactivity series, so here aluminium acts as a reducing agent and it will reduce the chromium oxide into chromium plus Al2O3, as here the oxidation state of chromium is 0 and the oxidation state of chromium, as we have find above, is 3. Here it acts as a reducing agent and the chromium oxide gets reduced into chromium. In this way we will easily extract the chromium by using such type of reaction. Next question, HCl2 plus YCl2, which is in axis, reacts with HCl4 plus Y, precipitate of Y is formed. This YO on heating at a temperature of more than 400 degrees Celsius forms half O2 plus Y. What we have to find, whatever will be the Y, the ore of Y would be. Here options are given, so we'll check what all options are there. Option A is siderite. Option B is cinnabar. Option C is malachite. And option D is horn silver. So what we have to do is, we have to first of all just we'll write the formula of all these ores. Siderite is what? Siderite is what? FeCO3. Cinnabar is what? It is a sulfide ore of mercury, that is HCS. What is malachite? Malachite is carbonate ore of copper, that is CuCO3. And what is on silver? It is a halide of silver, that is silver chloride, AgCl, as the name suggests. Now we'll see the reaction. What all reaction proceeds over here. What is given in the reaction? XCl2. X here is tin, that is SnCl2, when reacts with HgCl2. It forms what? Now here the tin, which is in +2 oxidation state, and the Hg, which is in +1 oxidation state, +2 oxidation state. Therefore the mercury gets reduced over here and the tin gets oxidized, so it will form SnCl4 plus Hg, mercury, that is Hg. Now this mercury oxide, mercurous oxide, mercury oxide, that is HgO, on heating at a temperature of about more than 400 degrees Celsius, it forms half O2 plus Hg. Now we have to identify what is the ore of Y would be. So the ore of Y would be what? Cinnabar.